Hi, welcome to video 6.10 on absolute value graphing and transformations. We're on page 13 of your purple packet. Okay, so an absolute value function, we're going to take a look at what that looks like in a little bit. It was one of our parent functions that we studied at the beginning of the year, and it looks like that. And then here is vertex form of it, and we'll talk a little bit more about that after we remember the original. So if I have my original, so I'll just use those values. So if I have f of x equals absolute value of -2, that's 2. And then the absolute value of -1 is 1, 0, 1, and 2. So it looks like this. And then hopefully this is bringing back memories of what an absolute value function looks like. As I'm approaching negative infinity, so as we're going this way, my slope is -1, and as I'm going this way, my slope is +1. Okay, so when we have a vertex form, something's happening here, something's happening here, something's happening here. So A is going to be the slope of our lines. Now, like if this is 5, our slope from this direction is going to be -5, and our slope in this direction is going to be +5. So it's the slope, but remember they're mirror images of each other. HK is going to be our vertex, and x equals h is going to be our axis of symmetry. So let's see why that works. That should be absolute value there. So if I do, let's do -2, -1, 0, 1, and 2. So if I put absolute value of -2 minus 4, that's going to be absolute value of -6, which is 6. -1 minus 4, it's going to be 5. 0 minus 4, it's going to be 4, and then 3 and 2, so 1, 2, 3, 4, 5, 6, 4, 3, 2, 1, and then it keeps going and goes back up again like that. So this time what happened to our vertex? It went 4 to the right. And yes, we could have found that looking in the function because our h is 4, so that means that our vertex would be 4, 0, because there's nothing added or subtracted there. Oops, sorry, couldn't see the bottom there. So 4 to the right and 4, 0. All right, let's take a look at the next page. And we're going to do a couple where we're using the information about our vertex form to sketch our graph without doing a whole lot of like plugging in points. So we can see from this that our vertex is going to be 1, 2, and our axis of symmetry is going to be x equals 1. And then our y-intercept, if we put in a 0 for our x, so if I have 0 minus 1, that gives me -1. Absolute value of -1 is 1, and then plus 2, so that's going to be 0, 3. So let's take a look at that. Our vertex is 1, 2, and then our slope is just going to be 1 because there's nothing in front of that, so it's going to go like that, and our axis of symmetry goes like that, and there's our y-intercept right there. So our slope is going to be -1 and 1. Our transformations are, it goes right 1 and it goes up 2. So go ahead and try this one and see how you do. Pause it and then you can come back. Okay, there are your answers for the second one. And let's do number 3 together because we've got something different that's happening here. So in this one, our slope is going to be the opposite. So this is going to be the opposite of -1, and this is going to be the opposite of 1, of what it was before. So they flip because this reflects over the x-axis. That's what that negative does. So reflects over the x-axis. And also this is going to go to the left 2, because remember it's x minus h, so that's like minus negative 2, so it's going to the left 2, and then it's going to go down 4. That makes our vertex negative 2, negative 4. Our axis of symmetry is going to be negative 2. And then if I put 0 in here, I've got 0 plus 2, so absolute value of 2, which gives me negative 2 minus 4, which is negative 6. So I have 0, negative 6. So looking at this, I've got negative 2, negative 4, so negative 2, 1, 2, 3, 4, right there. My slope is going to be 1, but it's going to be backwards of what it was before, so it's going to go like that. There's my axis of symmetry, and then there's my y-intercept, 0, negative 6. Okay, let's try another one. This time we have a slope that's not 1 or negative 1. We have a slope that's 1/3. So our vertex here is going to be negative 3, positive 2. That makes our axis of symmetry, x equals negative 3, and our y-intercept, if I put 0 in there, 1/3 of 0 plus 3 is 3, so 3 plus 2. 1/3 of 3 is 1 plus 2 gives me 3. So I've got 0, 3. So if I do negative 3, 2, right there, and then my axis of symmetry is negative 3. My y-intercept is going to be 0, 3, right there. Oops, I put this in the wrong spot. I'm sorry. Should be negative 3, 2. 1, 2, 3, right there. There's my axis of symmetry. Okay, so that makes more sense because my slope is going to be 1/3. So I'm going to go slope of 1/3, and over here, negative 1/3, like that. So as x approaches negative infinity, my slope is negative 1/3, and then over in this direction, my slope is positive 1/3. So my transformations are that it went to the left 3, it went up 2, and it grows slower because of that 1/3, or we can think about it as vertically compressed. Okay, I want you to try the next two, and remember, if you get stuck, you can always plug in points if you need to. So pause it and try these next two, and then come back and take a look at my answers. Okay, here are the answers for the last two. And please write down any questions that you had, and we will go over them in class.